Hello everyone, welcome back to our channel. So today we are going to see about the state and proof of Liapunov inequality, and the statement is if expectation of mod x to the power of r is less than infinity, is the rth moment, rth absolute moment about x of origin exist, then we need to prove expectation of mod x to the power of a whole to the power of 1 by a is less than or equals to expectation of mod y whole to the power of b to the power of b whole to the power of 1 by b. This is what we need to prove for all a greater than 0, b greater than 0 and a is less than b, because here in the inequality only we have mod x to the power of a is less than or equals to mod y to the power of b. So a is less than b. Now prove. In order to prove, consider a characteristic function which is phi of z is equals to z to the power of lambda for all z greater than 0 and lambda greater than 1. Here we are considering this because if z is less than 0, which is nothing but 0 into anything to the power is nothing but 0. Therefore, phi of z will become 0. Then how can we prove this one? So, we are taking z is greater than 0 and lambda should be greater than 1. If it is less than 1, which is nothing but 0. If it is less than 1 or equals to 0, then anything to the power of 0 is nothing but 1. So we cannot prove this one. So our z value should be greater than 0 and lambda value should be greater than 1. Now derivative phi dash of z with respect to. Then you get lambda into z to the power of lambda minus 1, which is nothing but x to the power of n. Derivative of x to the power of n is equals to n into x to the power of n minus 1. Right? And now the second derivative, phi double dash of z, which is nothing but lambda into lambda minus 1 into z to the power of lambda minus 2, which is the same formula we applied here. Now we have taken this function, right, which is nothing but phi of z is equals to z to the power of lambda is a convex function. In order to prove this inequality, we must use the Jensen's inequality. Jensen's inequality. We know that the Jensen's inequality is nothing but we take a function which is nothing but that is a convex function. Convex function ante entandi ikkada? The convex function is nothing but if you take any function and if you draw a graph to the function which is nothing but y is equals to x square, then your graph will be like this, the parabola. And if you join any 2 points in it, let us consider the x1 here and the x2 here, then if you draw a line connecting these 2 points, then that line will be the tangent line. The line will be the tangent line that is lying below the curve. This is the tangent line and it is lying below the curve, which is nothing but the Jensen inequality states that phi of expectation of x is less than or equals to expectation of phi of x, because here the tangent line is lying below the curve. That's why only the phi function applied to the expected value of x is always less than or equals to expectation of phi of x. So this is, you need to remember, this phi of z is z to the power of lambda. If you try to draw a graph to this, then you will get this type of curve, which is nothing but the parabola, and if you join any 2 points, then that line will be the below the curve, which is nothing but, which states that phi of expectation of x is less than or equals to expectation of phi of x. Here it is a convex function for alpha greater than 1. Therefore, by Jensen inequality, we can write this. By Jensen's inequality, I can write phi of expectation of z is less than or equals to expectation of phi of z. Right? Now, here we are lambda greater than 1. Now take z has mod x to the power of a, and lambda is equals to b by a greater than 1. Now substitute the z value. Here you have taken phi of expectation of z is less than or equals to expectation of phi of z. Then try to substitute this phi of z in this. Then you will get, therefore expectation of z to the power of lambda is greater than or equals to expectation of z whole to the power of lambda. This is what you get. Then consider this as equation 1. Now take z is equals to mod x to the power of a, and lambda is equals to b by a greater than 1, because we considered b is always greater than a according to the proof, as a mod x to the power of a is less than or equals to mod y to the power of b, which is nothing but b is greater than a. Now substitute this z value in this first equation. Therefore you get expectation of mod x to the power of a, here z is, and whole to the power of lambda. Lambda is b by a. Therefore b by a greater than or equals to expectation of z. Therefore expectation of z is mod x to the power of a and whole to the power of lambda, which is b by a. Now you get expectation of mod x to the power of b greater than or equals to expectation of mod x to the power of a whole to the power of b by a. If you cancel this a and this a, then you get mod x to the power of b, and you leave it this term as it is, because in order to prove this one, you leave one part as it is and cancel a to the one side. Then if you send this b to this side, it is in the numerator. So if you send this side, it will become the denominator. So expectation of mod x to the power of 1 by b is greater than or equals to, b into 1 by b is greater than or equals to expectation of mod x to the power of a whole to the power of 1 by a. This is what we need to prove. Hence proved.